Okay, good morning. Doing a little video here to go over 4D-Nos, which is multiplying polynomials. Should be pretty simple, just very much like the distributive property, except just a little bit more because sometimes we have some more figures here. So, if we're multiplying two polynomials, we need to multiply the terms of the first by the terms of the second, and then we'll combine like terms. Okay, multiply the terms of the first into the terms of the second, then we'll combine like terms. So if we have this polynomial right here, x plus 3 times 3x squared minus 2x plus 4, we need to multiply the x with the 3x squared, the 2x, and the 4. Okay, so we'll distribute the x through the 3x squared minus 2x plus 4. So x times 3x squared is 3x cubed. X times negative 2x is negative 2x squared. And x times 4 is 4x. Then we got to multiply the 3 and distribute it through the 3x squared, the negative 2x, and the 4. Okay, so 3 times the 3x squared is going to be positive 9x squared. 3 times negative 2x is going to be negative 6x. And 3 times 4 is 12. Okay, so that's the first step. What we just did here is we multiplied. Okay, we multiply the x through all these three things here to get 3x cubed plus 2x squared plus 4x. And then we did multiply the 3 through this whole thing. So we had 9x squared minus 6x plus 12. Okay, now we got to combine like terms. Well, 3x cubed, there's no other x cubes in here, so that kind of stays by itself. The 12 stays by itself because we can't really combine the 12 with anything, but we can combine the 2x squared with the 9x squared, and we can combine the 4x with the minus 6x. Okay, so when we simplify this thing down, we know that negative 2x squared plus 9x squared is going to give us 7x squared. So we can just take those out and add 7x squared here. And we have positive 4x minus 6x. Okay? Positive 4x minus 6x is going to be negative 2x. And then we'll just add the 12 back to it there. And there you have it. That's how you multiply a polynomial like that. If we have three or more polynomials, what we're gonna do is we're gonna do sort of the same process. We're gonna multiply the first two, put it in parentheses, and multiply the next polynomial. Repeat for however many polynomials are being multiplied. Okay. If you want to change the order up, you can. It doesn't really matter. I just think it's easier for us to stay organized to just sort of multiply the first two first, and then go from there. So looking at the x minus 5 times x plus 1. Okay, distribute the x through the x and a 1, and then negative 5 through the x and a 1. So we do that, and we get x squared plus 1x, and we have negative 5x minus 5. Okay, and we can simplify that down to x squared minus 4x minus 5, and we're going to put that in parentheses right there. Okay, now we have that in parentheses. We'll bring our other term down, x plus 3. And now we'll repeat the process like we just sort of did here. Okay, so we'll distribute the x squared to the x and the 3. So x squared times x is x cubed. X squared times 3 is 3x. Then we'll distribute the negative 4x through the x plus 3. So negative 4x times x is negative 4x squared. Negative 4x times 3 is negative 12x. Okay. Then we'll distribute the negative 5 through the x plus 3. So we'll have negative 5x minus 15. All right. So now we can combine like terms. X cubed sort of stays by itself. The x squared, we have negative 4x squared, and that's the only um, x squared term. Actually, check that. When we multiply the x squared, x cubed with 3x squared, we get 3x squared there. So we have positive 3x squared minus 4x squared, which is going to be negative x squared. And then we have the negative 12x minus 5x, which is negative 17x. Then we minus 15. All right, that's multiplying polynomials right there. So you guys can go ahead and do these 6 problems down here, finding the product of the polynomials there, simplify them down. And then down here, we have 3 binomials there, kind of like what we just did. You go ahead and knock those problems out as well. Let me know if you have any questions.